You're listening to the N2K Space Network.
Hey everybody, Dave here. Have you ever wondered where your personal information is lurking online? Like many of you, I was concerned about my data being sold by data brokers. So I decided to try Delete Me. I have to say, Delete Me is a game changer. Within days of signing up, they started removing my personal information from hundreds of data brokers. I finally have peace of mind knowing my data privacy is protected. Delete Me's team does all the work for you with detailed reports, so you know exactly what's been done. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for our listeners. Today, get 20% off your Delete Me plan when you go to joindeleteme.com/N2K and use promo code N2K at checkout. The only way to get 20% off is to go to joindeleteme.com/N2K and enter code N2K at checkout. That's joindeleteme.com/N2K, code N2K.
Space dulls the sense of taste. So, do you know what astronauts love? Hot foods. So yeah, up those Scoville units on orbit, drown your food in Cholula, munch on a Scotch bonnet like it's a bell pepper. You know, Dune was onto something. Space loves a bit of spice. And it ends up, so does NASA.
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger roll.
Today is September 26, 2024. I'm Maria Varmazes, and this is T-minus. Starfish Space gets spicy with NASA. New commercial partners for Trax. Rocket Lab completes Spacecraft number 2 for Varda. And our guest today is Jason Roberson, industry value expert in aerospace and defense at Dassault Systèmes. We're talking about virtual twins today. What are they? When are they useful? Well, we'll get into it in the second half of the show. Happy Thursday, everybody. Here's your intel briefing for today. We all took notice of Starfish Space's tenacity and dedication to the mission with last year's little otter pup that could ISAM demo last year. And undoubtedly, NASA did as well, as they just awarded a 3-year, $15 million SBIR Phase 3 contract to Starfish Space to complete a small spacecraft propulsion inspection capability mission, or the SPICY mission. It's in the name there. This is a mission to develop commercial inspection of inoperable satellites in low Earth orbit, which is a key step to be able to identify if there are opportunities to repair or deorbit spacecraft, which in turn will help reduce space debris. And notably, this is the very first commercial space debris inspection mission ever funded by NASA. Starfish's Otter spacecraft will be inspecting multiple defunct satellites as part of its mission, and they are all satellites that are firstly US-owned, and secondly, whose owners have consented to being part of this mission. And the Otter will get, in space terms, super close to these spacecraft, just a few hundred meters away from their targets, and determine important details about each satellite's spin rates, axes, and the condition of the target's surface materials. Expect the Otter to launch in late 2026 and to start making those spicy inspections on orbit in 2027. Slingshot Aerospace, ExoAnalytic Solutions, and COMSPOC have all been selected to participate in the Office of Space Commerce's improved satellite owner-operator Ephemeris Pathfinder. As part of this Pathfinder, the companies will provide LEO and GEO ephemeris generation services to support the development of the Traffic Coordination System for Space, also known as TRAX, which the OSC just announced will launch to beta users in the coming weeks. The Pathfinder will examine the effectiveness of generating improved orbit estimates, or ephemerides, which is satellite position, trajectory, and uncertainty information for satellites using data provided by satellite owner-operators. This would accelerate the path to leveraging owner-operator provided data in the track's conjunction assessment screening. Rocket Lab has completed testing and integration of its second Pioneer spacecraft for Varda Space Industries. Rocket Lab's first Pioneer spacecraft for Varda was launched in June 2023. Varda successfully crystallized the HIV drug ritonavir while on orbit, and Rocket Lab and Varda successfully landed the reentry capsule in the Utah desert in February 2024. The company is now preparing Varda's second mission, during which Rocket Lab and Varda will once again conduct in-space operations, reentry positioning maneuvers, and deorbiting to recover Varda's capsule. Varda received permission from the FAA under a Part 450 license earlier this month, making them the only company to ever secure a second reentry license. Voyager Space has successfully executed commercial payload activities via the company's Bishop airlock on the International Space Station. And during this mission, Voyager transferred 2 ARG-US multi-payload carriers and their associated customer payloads to the Airbus Bartolomeo External Science and Payload Hosting Facility using the Space Station Remote Manipulator System and Special Purpose Dexterous Manipulator, both manufactured by MDA Space. The ARG-US multi-payload carrier, which was built by Airbus US Space and Defense Space Exploration Team in Houston, is a payload accommodation platform that can host up to 10 smaller payloads on a standard Bartolomeo payload slot. Notably, this mission is the first time that the Bishop airlock has been mounted on the payload orbital replacement unit accommodation on the space station truss and used its second robotic grapple fixture. Black Sky has been awarded a U.S. Navy research contract to explore applications for advanced optical intersatellite link terminals on board the company's Gen 3 imaging satellites. The aim of the application is to give warfighters real-time access to imagery during time-sensitive military operations worldwide. The effort directly supports the Navy's Project Overmatch and the Department of Defense's Joint All-Domain Command and Control initiatives. As part of this study, Black Sky will modify its systems to accommodate an optical intersatellite link terminal that will be uniquely compatible with both the Space Development Agency's transport layer and commercial transport layers. Space robotics company Gitai has relocated its headquarters to a new office in Torrance, California. The new Space Robotics Space is more than 4 times the size of its previous location, supporting its business growth and increasing space robot production capacity. The new facility has everything the company could possibly need: a mission control room for the Gitai satellite, a simulated regolith chamber for lunar environmental testing, an endurance test area for the Inchworm robot, a dynamics simulation system for rendezvous and docking, a demonstration development area, a floating spacecraft simulation system, a workshop area, a walk-in thermal chamber, a thermal vacuum chamber, an environmental test area, a clean room for flight model spacecraft testing and assembly, a controlled assembly area, an avionics testing area, an office space, and meeting rooms. What else could you possibly want? With the expansion of its space robot manufacturing base, Gitai aims to further increase production capacity and strengthen its presence in the U.S. space and defense markets. And if anyone at Gitai is listening, I would love a tour. Just saying. Starfighter Space is expanding its operations to Midland, Texas, under an economic development agreement with the Midland Development Corporation. Starfighter Space operates a private fleet of F-104 and F-4 aircraft, conducting research and development for commercial and defense industries, as well as providing pilot and spaceflight training. The company plans to relocate at least $78 million in capital assets and equipment to the Midland International Air and Spaceport by 2027. Chinese rocket startup Deep Blue Aerospace plans to carry out another high-altitude vertical recovery mission in November, despite recent setbacks. The oxygen kerosene-fueled Nebula 1, which is Deep Blue's first reusable launch vehicle, completed 10 of the 11 key verification tasks during its first high-altitude vertical recovery flight test over the weekend. The vehicle did experience an anomaly in the final landing phase, leading to a fracture of the rocket body. But despite the test issues, the company says that the test could provide valuable data and experience, help them identify problems and deficiencies, and improve the performance and reliability of the rocket. Deep Blue plans to conduct a 5-kilometer high-altitude vertical recovery flight mission in November. The European Space Agency has called up its reserves. The ESA Astronaut Reserve Group will begin the first of 3 2-month training programs at ESA's European Astronaut Center in Cologne, Germany, in October 2024. The second group will start training on January 13th, 2025. This astronaut reserve training will cover selected modules of ESA's one-year basic training program, typically completed by career astronauts. The training will equip the members of the astronaut reserve with the skills needed to support Europe's future space exploration and scientific research. And that's today's Intel briefing for you. If you feel like a bit of extra credit, head on over to the show notes. Read up on the space-based solar power startup that's making waves. And Project HARP lives with Slingshot Space's new funding to build a space gun. I have the best job ever. Space gun. Hey, T-Minus crew, if your business is looking to grow your voice in the industry, expand the reach of your thought leadership, or recruit talent, T-Minus can help. We'd love to hear from you. Just send us an email at space@n2k.com or send us a note through our website so we can connect about building a program to meet your goals.
And now, a word from our sponsor, Cortex. Security teams face a barrage of more security tools create more complexity. More devices need protection. More specialized focus areas create more silos. The security landscape is changing fast. How can security operations transform to meet current threats? Cortex by Palo Alto Networks consolidates SecOps tools into an integrated platform and helps organizations stop threats at scale with AI, automation, and analytics. Learn more at paloaltonetworks.com/Cortex.
Today, I'm speaking with Jason Roberson, who is an industry value expert in aerospace and defense at Dassault Systèmes. And let's start off with the distinction between digital twins and virtual twins, because honestly, I thought they were the same thing.
You've probably heard of digital twins. That seems to be, I've heard that mentioned a lot. Well, digital twins, you've got a digital mock-up of your product. We'll call it a satellite. It could be a subsystem. It could be a rocket. Fill in the blank on what you want to imagine there. But a virtual twin then takes this digital twin into a science-based virtual environment in which that digital twin will live and operate and interact with other things, other satellites, other ground stations, the electromagnetic environment. So in this virtual twin experience, you bring all those virtual, all those digital twins together into a virtual environment. So it's connected, it's model-based, very dynamic, and then you can reuse it as you run simulations. You can go through potential scenarios that can be rapidly explored, predict future behavior, and then come up with precise solutions to be created for your products and your processes.
That sounds, it sounds amazing. And especially, I was curious how it sort of works in with simulations, because I think especially in really Gen Pop, we might think of these things all being sort of mashed up in the same, but they're not. As you said, there's a really interesting distinction between what comes in where. And the fact that the systems sort of, they feed into each other, and that the virtual twins get data from, that they pull in data as things are being run, that is really fascinating to me, that's even possible.
Yeah, it's definitely a continuously evolving and continuously improving, but there's so much data being generated today, and that applies to space systems and space processes and even geospatial analytic data. So all those feed into other processes. As you know, space touches more than just space. So space touches agriculture, it touches environmental things, it touches defense. There's so many aspects there, and so really working in space, you work across a lot of industries, and there's virtual twin capabilities or virtual twin opportunities in all those industries as well. So you can really have a system of systems of virtual twins to really improve efficiencies and products and really help your organization out.
Yeah, when we're talking about systems of systems, my brain goes, that could also maybe be really complex or sound extremely maybe complex or intimidating. My understanding of this technology is that it's getting really widely adopted. It's really changing a lot in the last few years. Has that also changed? Made things easier to understand? Has the barrier to entry sort of fallen a little bit on that?
Well, when so we could talk about the virtual twin piece, but I think what's we should probably look at is the barrier entry to space and how the virtual twin helps there. So I don't have to tell you that space is hard, but in the last 10 years,
tattoo it on my forehead.
Yeah. So in the last 10 years, we've seen the barrier to entry for launch has reduced a lot, with about a 10-time reduction in the cost to launch. So it opens up the end for a lot more people to enter the market, but then you still have the traditional challenges of technology and such. But one of the interesting pieces here is that last year, about 90% of launches were commercial. And if we go back 10 or definitely 20 years ago, you'd see the flip side of that, where most of them would be government, because it took really the treasure of a nation to get to space. But now it's a commercial market. Now, the other barriers to entry are your capital requirements, of course. You got to have expertise. Then there's navigating regulation, that's international regulation, and your host nation's regulation. And then, of course, there's competition. As the barrier to just physically get to space expanded, well, you get a lot more people with their innovation taking it into space. So it's an exciting time to be working in this industry. But the virtual twin can create, from your product to your process to your next generation, it can really fuel your innovation and improve your competition in the market.
Yeah. Can you paint a picture for me of how things have progressed over the last few years, given how fascinating this technology is? Where has it come from, and where has it landed so far?
Well, it started with 3D mock-ups, and there's still a lot of 2D CAD in play in the world, but there's 3D mock-ups, then creating completely digital products. Like you create your product basically on your laptop, and here it is before you bring it in front of your investors. You bring it to the factory. Speaking of the factory, we even have virtual twins of the factory, so you can design your factory, its processes and its outputs before you even break ground, to say, here's what this is going to look like, and here's how it's going to come together to build product X or Y and Z. We talked about in the past how expensive it was and limited it was, but in the past you'd build whole factories to build one constellation, and then you'd maybe adjust that factory to build a different constellation. Well, now you can build a factory to build, almost for mass production of satellites instead of bespoke satellites. We're seeing more. I mean, look at Starlink. They're turning those out, but others are coming into the market too with more mass production of satellites instead of just bespoke one-offs. Those are still there, of course, but being able to build those virtually, build how you build those virtually, and then have a right first-time product before it comes into the real world is really a game changer, especially when you look at virtual prototyping and testing of your product. If you test that virtually, especially the electromagnetic simulation, you can see how that's going to behave before you build the product. And one of the areas I've heard mentioned in many different forums, spaceports and launch infrastructure, the need for that to expand and grow. So I think there's a real opportunity for virtual twins to enhance our spaceport and launch infrastructure to improve efficiency, or see where we can expand, see what our surge capabilities are, et cetera. So, and then in-space logistics is an emerging area, the area of ISAM and others. So I think virtual twins, there's a lot of game to bring to those areas as well.
ISAM too, such a fascinating area that has always sounded very sci-fi to me, but it's real. And it's amazing what people are already capable of doing, and where that whole field is going is just amazing. I could absolutely see where virtual twins could come in there. I mean, especially since it's not going to be exactly easy to see what would happen when you're out there servicing a satellite. Not a whole lot of ability to test that on the ground. So that makes a lot of sense. Do you have any proof points or favorite examples of how the technology is being used today, and maybe how efficiencies have been gained?
We have a lot of customer stories across our 11 industries. And there's a few that are specifically for space in our aerospace and defense industry. There's stories from Anywaves, Interstellar Lab, D-Orbit, and NASA. And these stories, you can see where they're using portions of our solutions all the way up to the full 3D experience platform, where they virtually built their product before they brought it into the real world, and the advantages that they got from that. We're consistently evolving the capabilities as well. We invest a lot into our research and development to continue to improve products and processes and solutions for our clients.
I feel like I have to ask the obligatory question I ask in every interview nowadays about, like, where do you see AI fitting in with this? So I feel like I should just have like a cutout version of me asking that, because it comes up all the time. Is AI even, is that something that you all are interested in terms of how it interfaces with the product? Is that just hype, or is there something real there that could come into play?
I think it has to. I think, with what AI is bringing to all markets, you have to be integrating it into the capabilities. You can look at science fiction stories where you have AI co-pilots of space planes, etc. But I think it's really only limited by our imagination. So as we want to bring this innovation into the real world, it's going to be paired with AI in many ways. And of course, with virtual twins, you can automate intensive processes that are essential and have AI handle that, like space traffic management. That's going to eventually be a challenge that has to be looked at, and a lot of on-the-go activity has to be done in that environment. There's also predictive maintenance. Whenever we fly an aircraft and bring it back, we can get hands-on and do the preventative maintenance. But the data we're generating and AI being able to look at the data in a different way and a broader view of the data than we can help with predictive maintenance on our space systems, that we know when failures might occur, what we could do in a contingency, say that you lose part of your constellation or you need to surge to replace part of your constellation. That's where a virtual twin of your spaceport and these connected virtual twins could come into play, and the AI could help you generate those solutions. So I think AI is going to be integrated into a lot of space activities, from design, simulation, testing, as I mentioned, the spaceports, and then constellation operations as well. And I know there's a lot of great innovators out there working on AI specifically for the space industry, and even specifically for areas of space we just mentioned.
We'll be right back.
The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business.
Welcome back. I like to close out our show on an upbeat note when I can, but unfortunately today's story is a somber one, though an important data point on how space technology is helping us understand what exactly is going on with climate change. Microwave data measuring the extent of sea ice via jointly owned NASA and NOAA meteorological satellites is helping scientists better understand and demonstrate the degree to which we are losing polar ice, especially in the Arctic. Not a big surprise thanks to climate change that sea ice at the Earth's poles are shrinking, but by exactly how much? Well, we need to zoom out from Earth a bit to see. Polar ice levels, yes, they do fluctuate year to year. But what's the trend line overall for the last decade? The answer is, sadly, that the Arctic sea ice is shrinking by about 30,000 square miles a year since 2012. NASA's ICESat and ICESat-2 measure not only ice thickness, but also ice age. And their measurements have shown that on average, polar ice is getting younger. We have already lost some of the oldest, thickest ice at the Arctic. Nathan Kurtz, who is lab chief at NASA's Cryospheric Sciences Lab at Goddard, says, "Today, the overwhelming majority of ice in the Arctic Ocean is thinner, first-year ice, which is less able to survive the warmer months. There is far, far less ice that is 3 years or older now." May the day come soon when satellite observations on climate change is happy news. That's it for T- for September 26, 2024, brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T- are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth, who is still hunkering down from Hurricane Helene. Stay safe, Alice. Our associate producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karp. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm your host, Maria Varmazis. Thanks for listening. We'll see you tomorrow.